Hi, everybody. Welcome back. Today we're going to talk about a new concept called trophic level diagrams. I want you to get out a piece of paper or a Google Doc, however you want to do this. A piece of paper for some notes. You're going to do assignment on a Google Doc in a few minutes, but just draw a big pyramid or a triangle in the middle of it. Make it big, at least half the sheet of paper. And at the bottom, I want you to write down the word producers and plants. Again, this is my board from last year that I took a picture of after I had done this lecture. I've made some edits to it and made it better, but I'm just going to, this would be the picture that I would draw on the board, something similar to this for you if we were in the classroom. So go ahead at the bottom, the base of the pyramid, go ahead and write down producers. That could be like plants or anything that does photosynthesis and harvests the energy from the light from the sun and fuses together atoms and makes larger macromolecules like glucose or carbohydrates, for instance. You can see there in the red next to where it says producers, plants, you can see the word autotrophs. These are self-food. These are things that make their own food like plants. And you can also see 1,000 kilograms over there on the left side of where it says producers. The idea with that is I wanted you to imagine like the hillside out behind our classroom. If we were to take some shears and some lawnmowers and we were to cut down all of the producers and weigh them, how much would they weigh? Let's imagine that they weighed 1,000 kilograms. So now ask yourself, what eats producers? Well, that's consumers, right? And the one with the little zero next to it, next to consumers, means primary consumers. And what that means is these are the primary consumers that eat the producers. These are most often the herbivores. I've put an example of a deer there. And what I'm trying to suggest is that if you were to take the hillside behind our classroom and you were then to kill all of the herbivores and weigh them, in theory, they would weigh about 100 kilograms. And I'm going to tell you the reason why I know this in just a moment. But make sure that you draw this. This is a really important thing to draw. We're going to spend a lot of time here on this trophic level pyramid. Trophic just means a feeding pyramid, but it helps kids understand feeding relationships and how energy moves through an ecosystem. Well, who's going to eat things like deer? Well, let's say a coyote. So I've seen coyotes back on our hillside behind our classroom, along with big golden eagles, which are about 2.5, 3 feet tall. They're crazy big, huge predators, and they would take down a small deer, no problem. These are usually organisms that we call secondary consumers. That's the two with the little zero next to it. And if we were to then to kill all of these secondary consumers on the hillside, they would equal about 10 kilograms. Now, a kilogram is about 2.2 pounds, so it's about 20 pounds, maybe the size of maybe one coyote. So one secondary consumer on our hillside. That's about as much, I guess, food or energy that's available for a secondary consumer. Often these are omnivores, such as things like pigs that eat anything or bears that eat anything. Meaning, when I say that, I mean that they eat animals, but they also eat plants. That's an omnivore. At the very top, you get something like a mountain lion that would then come in and eat a coyote. And you can see in red there I've written carnivores. These are organisms that are true meat eaters. They do not eat plants at all. And I've written up there 1 kilogram. These are the tertiary or three with a little zero next to it consumers. Make sure that you draw that on your pyramid. And you can see over there on the left side of the screen energy flows. And what I'm trying to show there with my little sun down at the bottom is that energy is flowing from the bottom to the top of this trophic level pyramid. It's flowing and it needs, what I mean by flowing is that it's moving and then it's exiting as heat, as we learned in the last lesson. You need a constant supply of new energy from the bottom up to the top through the producers, up through the primary, secondary, and tertiary consumers. So make sure you just draw a single arrow, energy flows. The reason why I know these numbers like this is because there's a rule in biology, and it's called the 10% rule. And the idea is that as you go from one level to the next, you only retain 10% of the energy that was once existent in the level below it to the next level. And since energy equals matter in this case, like if a deer is going to eat plants, it's going to eat the matter of the plants and try to harvest the energy from that. We can say that energy is being lost just as matter is being lost as you go from one level to the next. What I think is really interesting about this is that if you look up there and you see the tertiary consumer, the mountain lion or the apex predator, that's what they mean by that. It's at the top of the pyramid, the apex of the pyramid. Do mountain lions weigh 2.2 pounds or 1 kilogram? And the answer is no. And that's why we could never have a mountain lion that would just live on the hillside behind our school. And in fact, a coyote, there isn't a coyote that lives back there. There's definitely coyotes that frequent the hillside behind our school, but they have to cruise long distances and they probably hang out at the river over by Freedom Park. They probably go under that wildlife tunnel up into Singletree. And the point is that there's not enough energy or matter on our hillside behind the classroom to sustain a coyote, much less a mountain lion. And so the mountain lions have huge ranges of maybe sometimes they go 25 miles in a day, and they're just opportunists. They're just looking for food the entire time that they're walking, but they can never settle down in one spot and then stay there, uh, similar to our hillside, because there's just not enough stuff there for them to eat. They can't eat the plants, and I guess they could eat a primary consumer, a deer. Maybe they could eat another primary consumer would be like a ground squirrel or a mole or a vole, or there's lots of little rodents that live back there. Mountain lions can eat those things, but they're not interested in hunting and using all the energy to eat those things. They want to eat larger things that have already eaten the primary consumers. It's only two other little bits of information I want you to put on your picture that you've drawn here. A big blue circle here that says matter recycles, and it's recycling from the bottom up through the top and around in a circle. And then way up there, whoa, sorry, way oh my, up there in the top left corner, I won't do that again, of the screen, it says ecom with a P. And what I'm trying to put up there is decomposers. This whole thing doesn't work unless there's decomposers. And that's what allows the matter of a mountain lion when it dies to be broken down and put back into the soil, these atoms, so they can come up as plants again and the whole process can start anew. But these decomposers, like bacteria and fungus and things like that, that break stuff down, they are essential. If they were not around, the whole thing would collapse and wouldn't work. Before I get rid of my picture here, I just want you to try this and see how hard this is. I think it's fascinating. Whenever I give a food web to a student, for them to try to put stuff in the food web and make it work. Try to use different organisms that I've just talked about on the hillside behind our school. If we were in class, I would give you this piece of paper and we would try to do it as an activity. I'll be quiet for a moment. It's kind of a hard thing to do. I'm going to show you a movie and then I'm going to go over a little bit more theory and then I'll give you an assignment to do. Food they eat. Okay, so again, we're back to our initial state standard here, 2.1A from the Colorado Department of Education. Analyze how energy flows through trophic levels. Now, we see a food web over here on your right side, that's fine, but you see on the left side a trophic level diagram. I'm going to show you a couple more pictures and then one or two more movies on trophic level diagrams. Here's a trophic level diagram. Obviously, you see on the left side with the producers, the herbivores, the primary and secondary consumers. You see that the web then is how they can kind of interrelate, and it's not always just kind of straight up from the bottom to the top. Once you start adding more organisms, you see a lot of kind of interactions that they have as far as feeding goes. Here's another picture of a trophic level diagram. Make sure to pause if you need to take a look at this more thoroughly. Okay, so here's our assignment. I've given you the pages from the Bird book. I've scanned them and put them on the Google Classroom. I certainly want you to read pages 69 through 72, answer some questions on page 72, and then it gets more specific about trophic levels on pages 77 and 78. I would have had you talk to your neighbor about the vocabulary on page 69. Maybe I should have you try to get in touch with your shoulder partner who you normally sit next to and talk to them about the vocab words there. If you have any questions, make sure to get in touch with me. What I'd like you to do is when you're done with this assignment, I've told you when all this is due. I'd like you to turn in the assignment from page 68, the questions 1 through 4 that you did in the previous assignment as a Google Doc along with this Google Doc and turn them both in now or the next in the next 24 hours or whenever I've told you to turn all the stuff in. Thanks. Let me know how I can help you.